yes. Okay, let's make sure I'm actually in focus. Keep that muted. Oh no, we don't have music. Ah! Let's see if I can fix that. Whoops. Nah, it doesn't want to put through sound. No. Hello, Sandra. Hello. Welcome. I'm trying to fix my sound. It's not putting music through on the stream for some reason. Oh, it might be that. Yeah, there we go. There we go. I had my volume down really low. Good evening. Oh, the light is right by the camera. This has gone quiet now. There we go. Keep that plugged in. Yeah, my band is playing a show for charity in November. So I've been down in Southampton this weekend, just gone, doing rehearsals for that, setting up all the backing tracks, and yeah, playing through some new songs as well, new songs that we've written. So that's been fun. And just generally been busy at work and stuff as well. But yeah, we're back, and today we are going to be recreating some features from one of my favorite game series of all time, of course, Legend of Zelda, because, you know, I recently re-downloaded the Link to the Past remake on the Switch. Not Link to the Past, sorry, Link's Awakening. Been playing that and watching a lot of videos, thinking about dungeons, and thinking about, like, actually trying to release something and get something commercial out and about. And because I love Zelda so much and love the general feel of the game, that was kind of where I wanted to go. And it's systems-wise, it's actually not that crazy. A lot of the stuff in there is actually pretty simple to implement. It's basically just player movement, some basic melee combat and inventory, and then the rest is just game design. So yeah, in this stream we're going to be kind of going through a tutorial, looking at how we can build out systems for a remake of The Legend of Zelda in a well-architected way, basically. I'm just going to pull up the stream on my phone quickly so I can make sure everything's running smoothly. Yeah, there we go. And I will keep this on here. It's the one benefit of not using my stream deck at the moment. I can use it as a a phone stand. Outrageous. Suzanne never came back with milk to a random teenager and she was very angry at me. Oh dear. Yeah, it's probably not the best thing to say to a random teenager. Yeah. Good luck with that would be the only recommendation I have. Okay, we've been going for 5 minutes, so let's hop on into Unity and start kicking this thing off, shall we? So, given that my screen is all updated, which I think it probably has. Oh, I need to fix my resolution, I reckon, because it's going to be, yeah, way too big. Boop, there we go. Hopefully that should be better. Gonna wait. Yeah, there we go. We should actually be able to see stuff on screen now. let's talk about what we've got here. It's a completely new Universal Render Pipeline project. It's a 3D project because, again, we're looking at Link's Awakening and the 3D or 2.5D remakes of the Zelda games. I've imported a couple of packages. We've got a package called Feel, which is what you'd guess, it's for game feel. Modern UI is just some assets for doing some of the UI stuff. Modular motion, again, UI animation specifically. I've created a folder called graphics, which I've imported some of the Kenny UI, Kenny board game assets into, mainly because there's a heart in there and we can use that for our heart UI. I've also got Odin, new input system, Cinemachine, kind of basic game prototyping packages, basically. We've got all imported into this project to get started with. But other than that, we are completely vanilla. I've done nothing in the scene, written no scripts. We're going to do everything live on stream today. So, as I said, this is going to be trying to approach this from the perspective of architecture, trying to make the game code as clean as possible, and it's going to be more like a tutorial. In the upload of this live stream, I'm going to put timestamps in the description so that people can look at the different sections. But the first thing I want to do is actually set up the scene. So let's go ahead and just set some settings on our camera first of all. I'm going to keep perspective because if I pull up a reference real quick to Link's in the box, Link's Awakening remake, and we take a look at some of the graphics here, you can see that there is some perspective on this. It's not a completely orthographic view. I'm not sure if games like Phantom Hourglass have the same kind of feel, or if they've still got some depth to them as well. By looks of things, it looks like, yeah, we've still got some perspective. So we'll probably use a perspective camera, but we're going to set up the angles properly. We're going to have the field of view be quite low, probably something like 35. And that way we still get a kind of orthographic feel to stuff, but it'll carry over for the visual. Sorry, I've just noticed my camera's completely broken. Let's see if we can fix that. What's going on there? What's going on there? Is it... I see what it is. It's my display capture is to window. Oh no, what have I done? I want to crop to the screen. Oh, this is going to be a pain. This is something I should have checked before I started. But hey ho, you know, we move, we get these happen. There we go. Looks like we're all fixed now. Please ignore the technical difficulties. Also, hello, Rishab, how is it going? Okay, yeah, back to the camera. So keeping it perspective, low field of view, so that we get some perspective, but it still looks kind of orthographic. I might even go as low as 30. And you'll see, I might demonstrate how this makes a difference when we get into it, if we've got a low field of view for a perspective camera. We're going to go to the environment settings, change it to solid color, and for the time being, I'm just going to go with like maybe like a reddy black or reddy grey, kind of something dark that's not pure black, because pure black is yucky. Yeah, something like that. Cool. I'm going to create a plane. It's going to be our ground plane. Going to reset the position of this so we are zeroed out. And yeah, let's create a player as well. We are going to create an empty. It's going to be our player object. Reset this as well. And our player object, we're going to use a character controller for our movement, because character controllers are just it's already set up to work for movement and stuff. So it's a bit nicer to work with than the like a rigid body system. So let's go ahead and pop a character controller on here. We're going to create our cube graphics as a child object. This is graphics. Move him up 0.5, and we're also going to remove the box collide from that. So now I have this this cube with a capsule collider inside it. Radius the same, height to 1, and we're going to move it up by 0.5 so he's in the center of our cube here. And then I am going to create a Cinemachine virtual camera. It's going to be our player camera. Actually, we're not going to call it player camera. What I'm going to do is I'm going to make an empty game object, and we're going to call this room. And I'm going to stick the ground plane and the player camera under here, and I'm going to rename this to room camera. So something about the classic Legend of Zelda games. They typically have like a room-based system or a grid-based room system. So when you move into a different area, it does a camera transition over, and we can recreate this with Cinemachine quite nicely by just setting up some collisions, basically some collision zones, and then having some room manager enable and disable the camera for the relevant room that we're in. And that's the approach that we're going to take here. So for this room specifically, it's not going to be too deep. We are going to take the room camera and angle it correctly. So I think it's a rotation on the X of 60. I think I'm going to go with 45. And we will go to our local editing and just pull this back until we've got everything nice and in view. And in fact, I am going to go for 60. It needs to be a high angle. There we go. So we can see here we've still got the nice perspective view. We can still see our shadows. Everything still looks kind of how it should. And if we go back to our reference for Link's Awakening, it kind of lines up nicely. The camera probably needs to be even further out, to be fair. Something like back here, just judging by the size of Link in this screenshot. He's actually quite small on screen. No, go away. Yeah, he's actually quite small on screen. Probably figure out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So yeah, if we assume each of these to be one unit, we're probably looking at about 24 units across. Yeah, that's probably a bit of an exaggeration. No, yeah, maybe 24 units across at the bottom. So what we can do, if I take my ground plane and just set it to 2.4, yeah, we can see here probably a decent size for okay, can I, oh, I'm moving the wrong thing, that's why. See a decent size for how we should have our camera position, and probably about here is going to be a good sort of size. I need to make sure I stay within the focus zone of my camera as well, so that it doesn't go out of focus. So that's our basic setup. What I want to do is just start to make this look a little bit better. So I'm going to go ahead on our directional light. I'm going to change this from filter and temperature to just a solid color. Set the intensity to 1. We're going to keep it white. And I'm just going to change the angle a little bit. Probably something like -35, -20. Oh no, I need to go bigger. Maybe -65. Let's go -50. 45. 35? I feel like -35 is probably the default anyway, but let's go with that. And then what we're going to do is we're going to give this kind of like a faux flat shaded look. And the way we do that is by going into our rendering and lighting, pull out the lighting tab here. If we go into environment, we can actually change the environmental lighting source from skybox to a color. And what this is going to do is basically exactly what you would guess. It's going to, instead of using the color of the skybox material, it's just going to use a solid color for our ambient light, and we can make this white. So now we actually get a kind of more almost clay-like feel to the way our scene is looking. And to help out with this a little bit as well, we can even drop the intensity of our spotlight to maybe 0.3. And you're probably thinking this looks dark. It does look kind of dark, and this is because Unity's default material is actually gray, not white. Final thing I'm going to do is just for environment reflections, I'm going to change this to custom. And then for the texture, we are going to use a white square. And this will kind of, it'll just make everything look nice and flat and smooth. No, it's going to complain if I just use a default 2D. We might have to make a cube map here. Rendering. Whereabouts is the cube map? I can never remember. We won't worry about it for now. We'll just leave this as leave it on custom, but without a texture. That'll be fine. So let's go ahead and make some materials. So under graphics, I'm going to make a new folder, call it materials. I'm going to make a new material for the ground, which I will drag and drop onto the ground here. And there we go. You can see already that's much better, because the new material that I've made is actually white in color instead of gray. I think we're going to go with a kind of a nice shade of green here. And then I'll duplicate this for our player, which we will have a nice shade of red going on here. We'll make it nice and saturated, something like that. Yeah. And it's going to be kind of interesting. I'm gonna pretend we got stone golems, and I've played around with this a little bit to make sure I'm on the ball with what I'm doing. So we're going to use kind of like a bluey gray for our enemies, placeholder enemies, create some dummies that we can bash around with. I'm also going to up the scale on Z of my ground plane to sort of 1.25-ish. Or let's do 1.2, because that keeps it round. So for anyone who doesn't know as well, a plane in Unity is actually 10 by 10 units. So if you've got it scaled as 111, it's going to be 10 across, 10 deep, and 0 high. So if you want it to cover, for example, 24 units, like I've got here, we'd set the scale on X to 2.4. And so we're covering 12 units on the Z-axis here as well. Okay, let's get straight into some programming then, shall we? Now that we've got everything set up here. I'm going to go under here, create a new folder in my scripts folder, and I'm going to call it player components. And I'm going to make two scripts to start with. We're going to make a C# script called player controller. I'm actually going to call it player data, I think. Yeah, player data. And we'll create another one called player... Ooh, let it load. Yep. Player movement controller, like so. And the reason for this comes into what I was saying about earlier with wanting to construct good code, or a decent code structure, decent code architecture in our thing. It's generally speaking, for the sake of good code practice, you should keep things doing as little as possible. A script should do what it says it does and nothing more. Same with methods. There's something called cohesion. You basically want scripts to be highly cohesive. So you can look at a script, see what it's called, and you can basically know exactly what it does from that. So we're going to separate everything out as much as we can, really. And part of that comes in having our player data separate to things like health management, movement, input, animations, combat. We're going to split all of these out into their own things. So pop open our movement controller as well. And we're going to start here. So I'm going to add a tag at the top, require component, type of character controller, because like I say, we're going to be using the character controller for this. And I'm going to start off by just removing everything from in here. Start with a clean slate. And we're going to create some variables. So we'll have a serialized field, be a private character controller. Controller. It's going to be our reference to our character controller. I don't think I need any other references for the time being. So next up, we're going to create a private float move speed, which I'm going to set equal to 5 by default. This is obviously how fast the character's going to move. We're going to have some other private things here. So the way I like to set up movement is I like to cache the velocity and use some smoothing as well. So we're going to have a few vector 3s in here. We're going to have private vector 3 target velocity, like so. Private vector 3 current velocity, and private vector 3 velocity smooth left, which you'll see why we have this when we get to actually making the player move. And finally a private float, which we're going to have serialized field, private float velocity smooth speed. North Game Studio, hello, how's it going? We are remaking some features from Legend of Zelda, starting off with player controller, so yeah, should be good, should be good. I think this is actually everything that we need for now. The final thing that I'm going to have actually is a public vector 2 called move input, which I'm going to have a get private set in here. Reason being, I might want to reference this for purposes of animations or for checking if other things are valid in other scripts. I want to be able to access data like move input to see if the player is trying to move, to be able to perform certain things. So let's go ahead and create an awake method, inside of which we are going to grab a reference to our character controller. So controller equals get component type of character controller. And then in our update method, we are going to do some few things. Turn up the mic. Ooh, yeah. Get my volume boosted. Oh. It's my cable. There we go. There we go. Yeah, I don't know what it is. This cable is it's a bit janky. Yeah, I need to try and get it fixed for sure. Thank you for the heads up though. Hopefully that is better. So in the update function, what we're actually going to do, we are going to just call other methods. One of these methods is going to be a public void. Does it need to be public? No, it doesn't. It needs to be private. We don't need to access this from anywhere else, so we're not going to have it exposed. We'll only have it in the player movement controller. It's going to be a private void handle movement. And all this is going to do is work out the target velocity, update the current velocity with smoothing to move towards that, and then move our character controller by that amount. So start off with the first step. Our target velocity is going to be equal to our move input, normalized, and we normalize this because basically what happens when you get input from a keyboard and mouse, or even from a controller or things as well, you end up having a situation where pressing W and D at the same time gives you, I think it's like 0.7, in like a magnitude of 0.7, sorry, a value of 0.7 up and 0.7 across, which gives you a magnitude that's greater than 1. So your character will actually move faster if you're moving diagonally. So we normalize it to make sure that the magnitude of our vector is always 1. And that way we can smoothly multiply it by our move speed. And that's going to give us our target velocity. Next up, we smooth the current velocity towards that value. So current velocity equals vector3.smoothDamp, which, like I say, is basically it smoothly interpolates from a current value to a target value over a given time. So we are going to pass in our current velocity as the starting point. The end is going to be our target velocity. We pass in a reference to our velocity smooth ref. And this is just a required parameter. I assume it uses it to figure out like where it's moving from, or so it'll do some calculation in the back end to kind of work out this smoothing. And finally, the smooth time will be our velocity smooth speed. And last thing we're going to do is move. So we'll do controller.move current velocity multiplied by time.delta time. Cool. Handle movement, let's call that in here. And actually, we're going to want to include some gravity because I'd like to be able to walk up and down stairs and things. So we'll come back to that in a second, though. For the time being, let's just have a look at this and see that this is working. One final thing we're going to need to do is actually get it so we're getting our move input from somewhere. I'm using the new input system, like I mentioned at the start of the stream, and I'm going to use Unity events for invoking behavior. So what I'm going to do is create a section down here called input methods. And this is just going to be where I'll have all of my methods that will call from the input controller. So I'm going to have a public void set move input, which will take a parameter of type callback context. I need to make sure that we are using Unity engine.input system.input action, and I'll just call this CTX. And what we'll do in here is we'll say if context.performed, so if the button has been pressed, we are going to say move input equals context.read value. We'll read a value from our input. The type is going to be a vector2, and that will give us the vector input from our keyboard or controller. Otherwise, if the context is cancelled, so you let go of the buttons, we're not pressing any buttons anymore, we're going to say move input equals vector2.0, just to make sure that it all levels out. Good evening, Matt. Welcome. Nice to see you around. I'm making Zelda stuff. You might find this familiar from the video clip I sent over in the Discord server the other day. Let me just move my focal point a little bit more central, because I keep moving. There we go. I think that's a bit better. Yes, good. So what we should have now, if I go onto the player object, let's drag and drop on this player move controller. We've got the move speed, velocity move smooth speed. I'm going to set to 0.25. Matt's never played a Zelda game in his life. That is outrageous. You're missing out, mate. You're missing out. It's a great game. Really good game. But no, seriously, you should play some. It's good. It's a very good RPG. Other thing we need is a player input component. We're going to hit the create actions button here because I like to have a load of default controls on my input actions. So I'm going to just call this controls. Leave it at the top level of the assets folder. And here is our controls. I'm going to dock this over on the right hand side of my game view, I think. I'm going to run out of space very quickly. I need a bigger screen. I usually use a much higher resolution when I'm developing, but for the sake of the stream, so that you guys can see stuff, hopefully it's like clear enough on screen. If I just close the chat, it looks like it's more clear than it usually would be. So hopefully you guys can see it. But yeah, I'm gonna run out of space a little bit, I think. Mate, if you've got a Switch, you need to get that Nintendo Online subscription and download the N64, Ocarina of Time, Majora's Mask. I mean, Ocarina of Time, that's the Zelda game. If you're of our generation, some people from a slightly older generation might say A Link to the Past is the Zelda game, and it kind of is. It was the first one that employed the Zelda formula, as it were, of go to a dungeon, get a key item, get an elemental thing, fight Ganon, Triforce, good job. But Ocarina of Time that's like the Zelda game. It is the Zelda game. First transition into 3D. Even today, like, it looks terrible, but it looks amazing. You know, it's one of those games. It's absolutely brilliant. And yeah, if you've got the subscription, that's a shame. Yeah, I'd be curious to know why that didn't work, because it's worth checking them out. And obviously they've got Majora's Mask on there as well, so you can play them all. But Majora's Mask is kind of hard, not gonna lie. So, yeah, we've got our player actions in here. We are going to change the behavior from send messages to invoke C# events. And what this does is give us a nice list of events that we can use to plug into various scripts. So underneath player, which if we look over here, we've got two action maps. We've got player and UI. Player by default has move, look, and fire. So we're going to go onto our move, add a callback here. We'll drag in our player movement controller and set the function to set move input. And now this is going to pass through the value of a vector 2 from our WASD or our arrow keys to say which direction we're moving in. So if I hit play now, we should be able to see our cube is not running around the place perfectly, because I've done something really funny. So you might be able to see I'm actually hovering up and down. We can move side to side nice and easy, but we're moving up and down instead of forwards and backwards, and this is because I've forgotten we're working in 3D. We actually need to do a new vector 3 here, and we're going to use move input.x for the x value, 0 for the y value, and move input.y for the z value, and then we'll normalize that. So reason being, obviously our move input is a vector 2, so we get a value on x and a value on y. Just knocked my thing. Let's make sure my mic's still working. Good. So yeah, we need to construct a new vector 3 because we want to convert this to 3D space. So we're moving along the x and along the z axis, not on the y axis, and then we'll normalize that. So I'm just going to decrease my move smooth speed as well to something like 0.1, so it feels a little bit more snappy, but we still get some acceleration. And yeah, there we go. So we've got, let's just zoom this in a bit. We've got a cube that can walk around the place, and it feels nice and snappy, and pretty good actually. So that's cool. How far are we in? Only 20 minutes. This is good. So another thing that we want to set up is some rotation. And we're going to start this off really simple. We're just going to make it so that it rotates to face the direction that we're moving in. The way I'm going to do this is actually, we're going to have an if statement here to say if, and I'm going to use current velocity. If current velocity is not equal to vector 2.0 or vector 3.0, sorry, then we will handle rotation. And the reason that we do this is with rotation, if you try and set things to 0, specifically if we're using quaternions, and we try and set stuff to 0, it complains. So we want to just do a check to make sure that we've actually got a value. And then if we do have a value, we'll actually update our rotation. Otherwise, we will not bother. We need to make sure that we're always updating our movement, by the way, for the sake of the character controller, for collision checks. A little quirk with Unity's character controller, which isn't so much a quirk, but more an efficiency thing. It only checks collisions for the directions that it's moving in. So if you haven't moved in a frame, it won't detect any collisions. Or it won't detect collisions on itself anyway. And that can get finicky when you're working with the grounded check. Because what you might do is have brain. You'll not move on the y-axis because you're on the ground, right? So you don't want gravity. You want to just be on the ground, and so you won't be moving. You won't be moving down. Therefore, it won't check if you're grounded. So grounded will be false because you're not moving down. It's really stupid, but it means that we need to factor in some gravity to our movement vector, and then it'll behave. And we do that. Yeah, let's actually do that now. So the way that we do that, if I leave everything where it was here, so we've got our current velocity. What we're gonna do is say if controller dot is grounded, we'll say current velocity dot y equals 0. We'll then add our gravity as the last thing we do. So current velocity dot y minus equals whatever our gravity value is. I'm just gonna hard code a value for now. Don't hard code values. We'll refactor it in a second, but we'll use -10. Yeah. So what this is going to end up doing is applying some small value of gravity to our velocity every time we move. And then in the next frame, when we've moved, it will do the collision detection, say that grounded is true. In the next frame, we get to this point, grounded will be true, so we reset our velocity to 0. And it means we won't accumulate gravity, but if we're falling, we will, because we won't be resetting our value here. So all that said, let's just go straight ahead and set our rotation directly. I'm not going to bother smoothing for the time being. We might do in a bit, but I'm not too worried about it at the moment. So we're going to say transform.rotation equals quaternion.look rotation. And as you can see here, this creates a rotation with the specified forward and up directions. So our forward direction is going to be the direction of our current velocity. And the up wait, can I do current velocity dot forward? No. No, it will just be the direction of our current velocity, and our up is going to be vector 3 dot up, simply. And it's as easy as that. So we'll look towards where we're moving, with up being up. Yeah. So now if we hop back over into Unity, we should see that our character is rotating and moving around the place. Which actually is going to be okay. So something kind of wacky's going on here. Oh, I know why it is. It's because current velocity has gravity in it, isn't it? So actually what we're going to do is we'll just use our move input, I guess. So yeah, we'll change our if statement up here to move input is equal to vector 2.0, and then we'll do a new vector 3 move input dot x 0 move input dot y, like so. Yeah, and actually we could probably make it a bit cleaner still by having our target velocity be the thing that we use, and that way we're not creating a new vector 3 twice. So let's go ahead and do that instead. And in here we will check that our target velocity is not equal to vector 3.0, and we know that our target velocity is going to be set because we have our handle movement being called first. Great. One last thing I'm going to do just so we can actually see this. I'm going to duplicate my graphics object here, and this is going to be our eyes. Let's go ahead and give Link some nice, or give our Link anyway, some nice eyes here. Scale in on this axis a little bit. As Danny would say, it's not just a cube, it's a cool cube. A cool cube. Duplicate this one. I'm going to call this eyes. I'm going to make it, I guess, like a white color. Why not? We'll pop that on the front of our cool cube here. You know what? I changed my mind. We're going to make it black. So now, yeah, we hit play and we will be able to see our character is walking around, rotating, snapping to the rotation that we want it to face. And this is all cool. I mean, it does look kind of janky. We'll add some smoothing to the rotation in a bit. But for the time being, this is fine. So, what we probably want to do now, I mean, that's one item off the list. That's our movement controls basically done. Just to prove that gravity is working as well, let's go ahead and wander off the edge here. Whoop. Oh, and there we go. We are plummeting down. Oh no, this makes me think the grounded is still returning false. Let's take a look. Switch this over into debug mode. No, of course it doesn't. Okay, let's see what's going on here. Let's do a debug.log controller.is grounded, so we can actually see if this grounded check is working, which, let's be honest, it probably isn't. Oh no, it is true. Fantastic. Okay, that's great. So then when we step off the edge, it becomes false, so our gravity value is just way too high, basically. Let's just maybe make this like minus 2.5. Yeah. And that way Link will fall a little bit slower. Cool. Let's do combat, shall we? So the way we're going to do combat here, we're going to use a animation driven system. Because what we can do if we're using animations, for one, we can enable and disable a hit zone. We can make sure that our ability to perform an attack is in line with the animation, so we can actually have the animation call a method on the player object to reset if we can swipe or not. And it also means we can have things like combos and it'll still work. We can have animations that are different lengths for different types of attacks, and we'll still get things resetting when they should. So I'm going to go in here and create a new folder in my scripts, and we're going to call this combat components, or maybe we'll call it damage components. And under here I'm going to create two C# scripts. We're going to have a Hitbox, and we're going to have a Hitbox. So what these are, we don't want to do anything crazy where we're like checking to see if the player collides with an enemy tag or things like that. We want to be able to independently control kind of how damage works, what things can do damage, where things can be damaged by. If we want to have things like critical hits, we want to have those. And we don't necessarily want things to take damage when they're hit or when they're hurt. It might be the case that, you know, we swing our sword and hit a crystal, and we want that crystal to change. But we don't want to have to set up a different system for interfacing with sword swing and a crystal. We want to just be able to say, if a Hitbox hits the hitbox of the crystal should do its behavior. So we're creating a hurt box, which is a component that will deal the damage or deal the call to say you should be hurt now. And then the hitbox will take that information and propagate it to whatever needs to listen to it via an event. So let's go straight ahead and do this. We want to make sure that our hurt box has a require component type of, and we're going to have collider component. There we go. And the reason I'm just saying collider is because maybe we want it to be a sphere, maybe we want it to be a box. Things like an explosion, for example, we probably want to be spherical or cylindrical, whereas the sword swing we can have as a box. We can use custom mesh shapes, doesn't matter, it'll all work. We'll have a private collider, I guess, hurt region. Or hurt collider, let's call it hurt collider. On our awake, we're going to say hurt collider dot. Yeah, no, we won't have it be a trigger. That's fine. Yeah, cool. We'll just have a public void. Oh no. Yeah. Ignore me. Do on trigger enter. Make sure that's private. We do want this to be a trigger, so we'll have an awake method that says hurt collider equals get component type of collider, and we'll also make sure that our hurt collider is a trigger. Hurt collider.isTrigger is true, and then on trigger enter. No, I've changed my mind. I don't want it to do it like this. We are going to ignore that. We are going to make use of the physics.overlap area. I think it's physics.overlap area. Because what we want to do is we want to damage everything that's within the region of our sword. Like if we've got 3 enemies stood in front of us, we want to swing and hit them all. Or if we do a spin attack, we want to spin and attack everything that we hit. So we're gonna do an overlap all and make sure things work. Once again, in the update, I'm gonna make a new method for checking for hitboxes, because cohesion. Private void check for hit boxes. I'm actually going to rename this check for hits because it's a bit of a nicer name. So we'll do var hits equals physics dot overlap, and I guess we'll overlap box, which goes against my original plan, but we'll come back to it. So we'll change this to require component of type box collider. You can be a box collider. You can be a box collider. We are going to overlap box all. I believe that's what the method is called. No, overlap. Oh, what's the method? Oh, wait, no. Overlap box does do, yeah, gives us an array. So we'll overlap box. We want to do it at the transform.position. We want our size to be hurt collider dot bounds dot size, and we're dividing that by 2 to get the half extents. Orientation is going to be transform.rotation. Layer mask, let's go ahead and get ourselves a reference to the layer mask. We'll have a serialized field, private layer mask, and this is going to be our hitbox layer. Pass that on in there. Job's a good one. That's that done. Let's do an if. We're going to say if hits dot length is greater than 0. We'll go ahead and iterate over each of these hits and do it some damage. So for each var hit in hits, var hitbox equals hit dot get component hitbox, and then we'll do hitbox dot hit, which is a method we haven't created yet, but we will create this method. What I'm actually going to do as well is create a struct to represent our hit data. So we'll have a public struct hit data, and we'll have hit take a parameter of type hit data. So I'm actually going to give some extra statistics to our Hitbox here. We're going to have a private void damage, not private void, sorry, private int damage amount. That's going to be it for the time being. In our hit data, I'm going to have two parameters. We're going to have a public int damage value. We're also going to have a public vector3 hit direction. Yep, and then we'll have a constructor for this, public hit data, which is going to take in an int for damage value and a vector 3 for hit direction. Yep. This is all good. We'll assign these here. Damage value equals damage value. Hit direction equals hit direction. And actually, I'm going to go back on what I said. We're not going to use overlap box. We're going to use box cast all. And there's a couple changes that we need to make here. We need a center, half extents, direction. So after the half extents, our direction is going to be transform.forward, orientation, and then max distance we are going to set to 0 because we want to just do it where it is. And that's going to return a list of raycast hits. So we're going to say hit.transform.getComponent. And the reason I've done this is because getting a raycast hit means we can get access to the normal direction of the collision. So in our new hit data, we can pass in new hit data. And this is going to be our damage amount. And then hit.normal. Although it'll be negative hit.normal because we want the direction that we're hitting, not the direction away from the surface that we've hit. Fantastic. Great, let's make our hitbox. So this is going to be kind of similar. We're going to have a public void hit. No, just hit. And this is going to take in hit data. And what we're going to have is a public Unity event of type, new public Unity event, please, of type hit data called on hit. We'll set this equal to new. And all we'll do in here as a base is say on hit dot invoke. And we use this question mark. We need to make sure we're passing in hit data as well. This question mark just is like a null check. It won't invoke this event if the event is null. And that's everything we need from a code point of view for this this hit system to take place. So hopping back over into Unity, we're gonna do a little bit of setup here. First thing I want to do is create a couple of layers for Hitbox and Hurtbox. So let's do that. Hitbox and Hurtbox. And then in our project settings, we're going to go into the physics, and we're going to turn off collisions for these things, all of the collisions, because we don't want them to interfere with the collision system at all. We just want them to be able to do their box cast, and for the hitbox to receive said box cast information. Cool. Yeah. So let's make something that we can work with here. I'm going to make what's called a training dummy, or what I've lovingly called a training dummy. So let's do that. I'm going to reset this again. We are going to move it back a little bit, and this is going to be where our lovely little textures come in. And we're going to take a little look into the physics system as well, which is nice. Move it 3 back on Z because I want it to be at the back. We're doing the same thing here again that we did with the player too. We're keeping the graphics separate from the implementation. So create an empty object called training dummy, under which I'm going to create a cube, which we will remove the box collider from. I'm going to call this base, and I'm going to set the scale to like 0.2, maybe 0.375, I think. There we go. And we'll need to move that up by a little bit as well, so he's not sunken into the ground. 0.2. That feels wrong, but it isn't apparently. Cool. Let's duplicate this again, and this is going to be the head or the body. I'm going to make this 0.75 tall and 0.5 wide. Move this guy up a bit. You know, he's a bit small actually. Let's make him 0.75 wide, and maybe 1.25 tall. We'll make him a nice big dummy boy. Make this base 0.5 tall as well. There we go. So we've got this thing on a stick now. By the way, if you're new here, or even if you're not new here, say hi, have a convo. It's nice to chat to you guys. And of course, if you have any questions about any of the code that we're doing, it's good for me to know, so I can try and explain. Because often I get in a bit of a flow state when I'm coding, and don't explain stuff properly. So I've just added a rigid body to both of the base and the body. I'm going to make the base kinematic, and the reason I'm doing this is I want to have a thing so that when we hit the training dummy, it'll wobble in the direction that we've hit it. That way we can test out our vector direction is working properly, and we can also maybe have a pop-up for the damage as well that says how much damage the thing has taken, and that should be quite fun. So base is going to be kinematic. We don't want this to use gravity. We want it to just stay completely still, rooted into the ground. The body, we are going to not use gravity. We are going to leave everything else as is, and we're going to use a what's the joint called? Configurable joint, which is Unity's most complex joint, but also the most versatile. So we can connect our base in as the connected body for our body here. This just means that the body is connected to the base. I want to change the anchor to -0.5. As long as I've got my scale right. Let's make this a bit bigger here so I can see what's going on. Make sure he's on point as well, so we can see actually there's our little joint. It's really small in there, but there's a little yellow arrow down the bottom. So we'll just make sure he's stuck on there nice and good. I want my connected anchor to auto configure. And the motion, how do we want to do this? We want to lock the Y angular motion because we don't want it to rotate on the Y axis. We also don't want it, you know what, let's hit play. We can experiment with this. So at the moment, that's fine, that's just Unity throwing errors. So at the moment we can move this around and it's kind of not doing anything. We want to have some drive on here, so we're going to have a positional drive. No, we'll start off with an angular drive. We're going to have some spring drive on here. Hello, you gonna do your thing? No. There we go. Oh, where's he going? My guy, come back. There we go. This is kind of what we want. I think I want to lock all of the positions. So that way, yeah. It's just like, it just jiggles. Which is fun. I'm going to up the spring strength to 50 and drop the damping to like set it to like 20. What's that going to do? Too much damping. Maybe like 2. Bit higher than that, 5. Let's go with. There we go. So now we get a bit of a jiggle going on here. If I set this to 0, it's just going to keep going forever. I actually want it to be a bit more springy. I might up this to 100. Yeah, there we go. Nice and springy. Yes. Set our position damper to like 0.75, I think. So now, yeah, we get this this good jiggle, which is cool. We can properly bash this poor dummy in, and it's going to look really cool. So I'm just going to go ahead before I exit out of play mode, because exiting play mode destroys all of your progress. I'm going to click on the 3 little dots up on the configurable joint and copy the component. Exit play mode. Go on here, paste component values. So now this is how it was when we were in play mode. And I'm going to go ahead and just make a material for the dummy as well. Dummy, which we will put on here. And like I said earlier, we're going to make this kind of like a cold steel, kind of stone looking material, something like that. Yeah, perfect. I want to change all of these to simple lit as well instead of lit, because I'm not fussed about things like reflections and stuff. I want this to look flat shaded. So that's all good. And one final thing I'm going to do is just duplicate this material once again. I'm going to make a material called Hurt Flash, which is going to be just red. And we're going to give it some emission, which is also going to be red. Going to make it like a bright red. And let me just drag this onto here so I can see how it looks. Make sure we got our post-processing on, which actually we don't have a post-processing volume, so let's go ahead and create one of those. Global volume. URP already has a profile with it, so we're going to make use of that. I'm just going to remove the tone mapping because I don't like it. And we've got some bloom on there, very nice. So let's go ahead and change this hurt flash a little bit. I only want it to have an intensity of maybe like 1.2. Gonna make it nice and bright. Yeah, nice shade of red. Let's just whack this all the way over here. Great, and that means we get a bit of glow on there. Cool tricks. So let's actually set up some hurt zones for this dummy. So first thing that I'm going to do is create a box collider on the thing. This isn't going to be our hurt box. This is just going to be a collider so that we don't walk through the dummy. I'm going to go ahead and just edit the bounds. We are going to make it flat to the bottom of this thing. Flat to the top. Scale this in so that it's about the same on each side. I just pressed 3 as if I was using Blender. Oh my days. Like so. So it's going to be what? 0.75, 0.75, 1.5 and 0.75 there. And that gives us our dummy. Fantastic. Next up, I'm going to create an empty, and this is going to be our hitbox for the dummy. So let's go ahead and drag and drop our hitbox component on here. I have not given my hitbox the requirement of a box collider. We need to make sure that it has a box collider because obviously we need the hurt box to be able to overlap with something. If we don't have a collider on there, it's gonna fail. So let's go ahead and pop that on. Give it the same dimensions, 0.75, 0.75, and what was it, 1.5? Go ahead and move this up so it's in the right position. And we're gonna put it on the hitbox layer. Cool tricks. Let's make a actual script for our test dummy. So I'm going to make a new folder called test components. Going to make a new C# script called training dummy. Pop this open in Visual Studio, and this is going to be a really simple script. We are simply going to say serialize field, private rigid body RB, and we'll have a public void receive hits, which will take in some hit data, and we will say body RB dot add force, hit data dot direction multiplied by data dot damage value, and we'll multiply this by some like hit multiplier, hit force multiplier, which we'll create in a second, and the force mode is going to be impulse. Let's go ahead and serialize field private float hit force multiplier, which I'm going to set to like 2.5. And that's it. That's all we need for our training dummy for the time being, at least. We will drag and drop this onto our test dummy. Rigid body is going to be the rigid body on our body, funnily enough. And the way we're going to do this callback is on our hitbox. We're going to add a listener on the onHit event, drag in our training dummy, and fire off the receive hit. Simple as that. So what I actually want to do, I want to go into our controls now. We're going to set up the player to do some attacking, and this is going to involve creating some animations and having a callback for our hit. So I'm going to change fire to attack, just double clicking on there. This is going to be a button. I actually want to use the J key because I don't want to use keyboard and mouse for this. I want it to all just be on the keyboard. There's no need to have the mouse involved because it's not a twin stick or anything. So there it is. It's just J. And I think actually for controller, I'm going to use gamepad button west, so square. No, I'm going to use circle, so button east. Save asset. That's now going to update all of our input assets over on our player controller. And let's go ahead and make some animations, shall we? So, real quick before I get into that, I'm just going to make some prefabs. We're going to save our training dummy as a prefab, and I'm going to save my player object as a prefab as well. Cool. Underneath our player object, let's go ahead and create an empty, and this is going to be our player. No, I'm not going to do that. This is going to be our weapon, our sword. Like so. Underneath which, yeah, I do want to do it like this because this way we can have different weapons if we want to. So under here, I'm going to create another empty called sword graphics, and another empty again, which is going to be our Hitbox. And actually, this is going to be our sword slash Hitbox. And let's go ahead and put the Hitbox component on this. Damage amount is going to be 1, I guess. Damage layer is going to be Hitbox. And I'm then going to duplicate this, and this is going to be our sword spiral Hitbox. And you can probably see why this is going to be the case. So we can do 3 damage with a spin attack, 1 damage with a normal attack, which is cool. And then we can actually set up these colliders to be in different zones. So let's go ahead and reposition our spiral attack. I want our spiral attack to extend out 1 unit around us. So let's make this 3 on each of the axes. So there we go. Anything within this region is going to get injured. And then the slash Hitbox we are going to put directly in front of us. So we're going to move it 1 unit forwards. And I'm going to make it 3 units wide. Yeah, maybe 2.5 units wide, because otherwise the swing radius is going to be huge. And that's also kind of hard to see because it's green on green. Maybe let's go in and change our ground color. As much as I like green for the ground, perhaps we can use like an earth type color, or something like wood. Yeah. Something like this. And that way we can see our gizmos a bit more clearly. Hopefully that translates on the screen for the stream. So we've got two hitbox regions set up now. Very cool indeed. Let's make our actual sword graphic. I'm going to just go ahead and move this out over here a little bit. Negative 0.55. Let's make it negative 0.6. And we will move it up to 0.5 on the y-axis as well. And let's go ahead and create a cube, which is going to be our blade. I'm going to make it 0.25. No, 0.25 on y. We're going to take off the box collider as well. We don't need it. This is purely visual. We are going to make it 0.1 on that axis. And on the z-axis, you know, I might make it a little bit shorter still, and we'll just move it forwards so that the it's like the hilt is there, so we have our sword graphics. Oh, that's so funny. Let's make a material for this as well. Sword blade. We're gonna make this like a light blue steel kind of color. There we go, kind of metally. And we're also going to add on a trail renderer, because trail renderers are always fun. Going to give it a time of 0.2, min vertex distance of 0.01, and we need to set a material on this as well. So let's go ahead and just use our sword blade material. So we can see here now this thing has a trail on it, and it's actually kind of ridiculous. We're going to do some things with the width here so it looks a bit nicer. Yes, very nice. I don't want to align it with the Z transform, but I also don't want to align it with the view. I wonder actually if let's make this as an empty underneath. Copy component. I will remove it from here. We're going to paste it on here. And then we can actually rotate this. Brain, please work 90 degrees like that. And then when we move our blade, yeah, there we go. Boom shakalaka. I am going to use a different material for the sword trail, which I'm going to have some emission on. We're going to make it white, give it a bit of glow. Am I going to do that actually? Because it doesn't support transparency, I don't think. And I want it to fade out over time, basically, is what I'm looking to do here. Color over time. Let's take the alpha here and drop it down to 0. Bruh, why is my blade still... Sword blade, transparent, blending mode, alpha. Yep, that's all fine. Receive shadows. We're using the sword blade material here. Where's my alpha value? What's going on there? Unity just doing me dirty. I think they are, you know. It'll do. So let's get on and make some animations for this. So we're going to have open our window. We're going to animate this on the player object. Yeah, we're going to animate this on the player object. Yeah, I'll animate it on the player object. That's fine. We're not going to change swords. So weapon, window, even animation. Gonna dock this up here. No, not up there. Up here. There we go. See what I mean? Too many things. Let's create a new animation. We're going to go under graphics, animations. I'm going to make a new one, player, new folder again, combat. And this is going to be our sword underscore idle. And And this is going to be a really simple one. We are just going to make sure that we disable our hurt boxes, turn off the hurt boxes, and we'll disable the trail as well. I'm also going to put an event on here, which at the moment isn't going to do anything, but what it's going to do in the code is it's going to reset our attack so that we can press the button again to trigger a new attack. Cool. Let's create a new clip. We'll call this attack sword underscore attack underscore 1. Just hit record on this, and I'm going to go from top view. I want to very quickly enable my slash hurt box for 1 frame. I'm going to turn that on and then turn it off straight away after. We are going to turn on the trail for the entirety of this thing. And I'm going to take my sword graphics and do some funky stuff. I'm going to rotate on Z to 90 degrees, negative 90 degrees. And we're going to start here with a rotation on X of negative 90. Nope. On Y of negative 90. And then we're going to go over to like frame 50, and we're going to just invert this. So it's going to be positive 90 now. We're going to be positive 0.6. So there we go. We just get a nice swipe. Let's make that a bit faster, shall we? Swipe. And then what we can also do is head into our curves and just make that look a bit nicer. Unity, please. So let's start off with the curve of our rotation. I want the Y rotation. It's going to start quick and then go slow. And we'll do the same with our X position. We'll have to zoom in a lot for this one. Come on. Tell you what, Unity's animation screen is not the most intuitive. I love it, but it's not great. There we go. I think I'll make this even a little bit faster, maybe like 10 frames. Did I have it 15 before? Yeah, it's too slow. 10 frames. Nice and quick. We love to see it. So let's go back onto our sword idle. I forgot that I need to set the rotation and position back to normal. So let's go ahead and do that. We want our blade's rotation to be 0, 0, 0. That's fine. And rotation can be as it is here as well. Ugh, not the blade, not the blade. Sword graphics. 0.6 and 0, 0, 0. Cool. I'm gonna copy these keyframes, and we're gonna do the same thing for a second attack. Sword underscore attack underscore 2. And I'm gonna have to start moving kind of quick because my computer is running low on battery and my charger is in the other room. Yep, so this is going to be exact same thing. We're just going to flip the position and rotation frames so it goes in the other direction. I think we'll also have to sort out our curves because they'll be curving in the wrong direction now. So you're going to curve down like this, and this one needs to be flat. Same with our Y rotation. Let's fix that one. There we go. Nice. So now we've got swipe in both directions. Cool. Yeah, and that activates and deactivates our hurt boxes as well. I'm going to just go in and disable these by default to make sure we don't have any weird stuff going on. And final thing that we're going to do is create our attack sword underscore spiral underscore charge, which let's make a particle effect. Yeah, this is I'm getting deep into it now. Having way too much fun. So we're going to make a particle system effects, particle system right. Particles are always kind of messy. They're always kind of fun to work with. We're going to use a box. Let's get our sizes all set up correctly. So we want this to be yay tall. We want it to be yay wide. We are going to emit from the shell. We're going to have a start speed of like 0, but we are going to set the velocity over lifetime on the Z as a curve, and I want it to slowly increase. I think we'll actually set this to something like 5. We're going to set the start lifetime to 0.2, maybe 0.3. Let's change the material that we've got going on here as well. Under renderer, we will go here. I'm just going to use sprites default. We will set the start size to some random between 2 constants. And those 2 constants are going to be 0.2 and 0.4. We are going to randomize the start rotation between -180 and 180. We are going to have some radial, no, I want orbital on the z-axis. So these are spiraling around. In fact, I'm going to make these even smaller, like 0.1, 0.2. Size over lifetime. Let's have them scale up and then down. Like this kind of thing. Maybe set the rate to 20 so we get a few more. So we get this cool looking charge effect going on now. Oh, there's my low battery notification. Oh, I've only got 15 minutes as well, to be fair. So I'll tell you what we'll do on this stream. Let's make the basic attacks, and then next stream we'll sort out our spiral. So I'm going to make a new script under my player components. C# script. This is going to be a player combat controller. We are going to have a serialized field, private animator, combat animator. And actually, we don't even need this to be a serialized field because it's on the same object. We can just grab it from our components. Let's do that in awake. We're going to say awake combat animator equals get component animator. Let's set up some input methods as well. Public void trigger attack, or get attack input. Again, callback context. And for the time being, all this is going to say is if context.performed and can attack, we will perform attack. So let's do that. Let's make a private bool can attack, which will be equal to true by default. Yeah, I don't even need to do that actually, and we'll see why in a second. Public, we'll keep this private void perform attack, and all we're going to do in here is say can attack equals false, and combat animator dot set trigger attack. And we'll also pass in combat animator dot set int, and we're going to do attack index, and this is going to be equal to we're going to track some things. We'll have private int previous attack index. We'll say var attack index equals, and we're going to just check, say previous attack index is equal to 1. If so, we'll say it's 0, otherwise we'll say it's 1. And then we can say previous attack index equals attack index, pass in our attack index here as well. And we'll also have a public void reset attack, which will just take it won't take anything. It'll just say can attack equals true. Okay, let's set this up on the animations. So player object, first of all, let's go ahead and drag and drop our player combat controller on here. We're going to assign the event to our attack button. Whoop. Player combat controller, get attack input. And then let's set up our, can I say please? There we go. Set up our animator. So pop in open on here. Let's create some parameters. We're going to have a trigger called attack. And we're going to have a integer called attack index. And this is going to be nice and simple. We won't worry about our spiral charge yet. All we need to do here is make a couple of transitions between our idle and our attack. We're going to say to go into our attack from the idle, we'll have a very small blend so that it's at least a little bit smooth. Maybe bring that across just a little bit. So we start there and then we slice. Not going to have an exit time. We are just going to say when attack is triggered and attack index is equal to 0. Coming back, we're going to do the opposite. We are going to just blend it in so it swings and then comes back down. Nice and easy. And this is going to have an exit time on it now. Cool tricks. Similar thing on the opposite side. We will have a little bit of a blend in so it looks kind of smooth at least. We are going to say when attack is triggered and when attack index is equal to 1. No exit time on this one. And then transitioning out again, have a little bit of a transition on the tail end here with an exit time. And that's just going to swing us back. All nice and good. And that's actually it, I think. Theoretically, if I've done everything right, let's just turn off the particle system here as well. So I should be able to walk around normally. Oh, yeah. Last thing we need to do, let's go on to our animation for our sword idle. Remember this event that we created earlier? We're going to go ahead and assign this to the reset attack method on our player, making sure that we've got our player selected when we do this. There it is down at the bottom, reset attack. And I also want to make sure none of these animations are looping because they shouldn't be. So let's go ahead and disable all of those. And now, all being well, we will be in a great place to close things off. We can walk around, we can press J, there's our swings. I think the blending is doing us dirty here, but we can also, we can't attack our thing. Why can't we attack our guy? I wonder. Okay, let's do some debugs. So on our hitbox, I'm going to do a debug.log transform transform.name was hit, and we're going to do a similar thing over on our hurtbox. I'm going to say in here hurting hit.transform.name. And I reckon the problem is probably that I haven't put it on the right layer. So let's go ahead and sort those out. We will take our hurt boxes here and put them on the hurt box layer. And our training dummy is hitbox. Yeah, that's on the hitbox layer. Good. Oh no, it probably is the transitions. Yeah, we wanna go straight into it. So let's just sort those out real quick. You need to happen straight away, and you need to happen straight away. And let's just sort our transitions back as well. Exit time 1, transition duration 0, transition offset 0. Save up. Let's have a look. So we can walk around, we can swing our sword. And now, no, it's still not hitting anything. It looks like our hurt box isn't getting enabled. But it should be... Oops, wrong button. I've ISG'd. So that's hitting now. Yeah, I think it's just it's not getting enough time, maybe. Though it should be, because we're running the full animation. Oh, there we go. Right, I've done something wrong with the way that I'm doing the box cast then, I think is probably what's going on here. But let's just let's make sure this is all going on properly as well. I'm going to up the damage of the slash hitbox to 4 just to make sure we get, yeah, there we go, big swing. Big swing. Cool. So yeah, we are doing some damage here. We are landing hits. There's just something kind of whack going on with my my hurt box. Which is interesting. I think it is. It's going to be something that I'm doing in here with my my box cast. Let's see, we've got the position. Half extents is the size over 2. Direction, orientation. Yeah, this will be something I work out. Maybe we can draw out how much battery have I got. 3%. Okay, I don't think I will have time to finish that off, but that's our first start. So in the next stream, which I will hopefully do this weekend at some point, we will be looking at fixing that system, getting the spiral, and maybe looking at some things like chests and stuff as well. So hopefully you enjoyed this stream. Anyone who was watching found it helpful, or was interested at least in seeing the code process. If you did enjoy and you're not already subscribed, please consider hitting the subscribe button and leaving a like on the video. Let me know in the comments what other stuff you want to see. Yeah, if you're not in the Discord server already as well, make sure to join the Discord server as well to get notified of when I do streams, when updates to games happen, what we're doing inside the team. And yeah, thanks very much for coming along, guys. I will see you